Hello, Year 9. This is Miss Teresa. Today I will be talking about hydraulic system, which is still a part of our lesson in pressure. Our lesson objective for today is to understand the working of hydraulic systems. And success criteria, I can explain the working of hydraulic systems and how force is magnified. This is a simple representation of hydraulic system. A simple hydraulic system consists of two movable pistons. The piston with a smaller area is called the master piston. This is where we apply the force. And the piston with a larger area is called the slave piston. The two pistons are connected by a pipe which contains a certain fluid. They use fluids because they are virtually incompressible. The fluid used in a hydraulic system may be water or oil. There should be no air bubbles inside the system. A small force applied on the master piston will create a pressure in the system, and this will magnify the force, and in turn, this force will be able to lift extremely heavy objects. Hydraulic systems follow Pascal's principle, which states that when a fluid is at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the walls of the container. The original pressure, P1, exerted on a small piston A1 will produce an equal pressure, P2, on the large piston A2. The relatively small force, F1, applied on the small piston will result to a magnified force, F2, on the large piston. Since P1 is equal to P2, then F1 divided by A1 equals F2 divided by A2. This equation is essentially the Pascal's principle. Some examples of hydraulic devices are hydraulic lifts used in car repair shops like this. Other examples are hydraulic jacks for your car, hydraulic brake, hydraulic press, cladding machine, brick making machine, etc. You can search the internet on how do they look like, and they all follow hydraulic system, the Pascal's principle. The next part of our video is to answer IGCSE type questions. So this is the first question. A farmer uses hydraulic system to operate machinery that is pulled behind a tractor. Two cylinders and a flexible pipe that joins them contain oil. Two pistons keep the oil in the cylinders, and the arrangement is shown in the figure. Okay, let's go back. Yes, okay. Let me just annotate that. So the cross-sectional area of the smaller cylinder is 0.048 meters squared. This is A1. Okay, how do you know it's A1? It's the smaller one. Smaller one is always A1. Okay, so cross-sectional of the larger cylinder is 0.14 meters squared. This is A2. Okay, and then the smaller piston exerts a force of 12,000 Newton on the oil. So this is your F1. How do you know it's F1? Because you exerted it at the smaller piston. So we are asked to find for the pressure in the oil, P1. Since P1 is equal to F1 divided by A1, then we can use the given already there. So P1 is equal to F1. F1 is 12,000 Newton divided by A1. A1 is 0.048 meters squared. Okay, so to calculate that, 12,000 divided by 0.048 is equal to 250,000. So 250,000 Pascal or Newton meter squared. But we're going to write this in standard notation, so it's equal to 2.5 times 10 to the power of 5 Pascal. Do not forget the SI unit. You'll lose marks for that if you forget it. Okay, second part of the question. Same question, different condition. So this one. Wait, please. Sorry about this. Okay. So, same question. Now we're going to solve for the force exerted on the larger piston. Okay, so we know that P1 is equal to P2. And the pressure that we solved earlier is 250,000 Pascal. Okay, this is the P1. And P1 is equal to P2. Now we are asked to calculate for force exerted by the oil on the larger piston, F2. Okay, so we know that A2 is this one, A2. So we'll calculate that. Okay, we know that P2 is equal to F2 by A2. But we are requiring F2, so F2 is equal to P2 times A2. So P2 is, we already know, 2.5 times 10 to the power of 5 times A2 is 0.14 meter squared, 0.14 meter squared. So you just multiply that times 0.14 meters squared is 35,000. So the answer to this question is 35,000. The SI unit of force is Newton. So this is the answer for this second part of the question 1. Okay, so next, number 2. So for number 2, figure 4.1 represents the part of the hydraulic braking system of a car. Okay, the force F1 of the driver's foot on the brake pedal moves piston X. Okay, yes, so the brake pedal is moved by the foot on X, and that's the smaller area. Okay, the force F2 exerted by the oil moves piston Y over here. This is piston Y, this is piston X, the small one. The force is applied to the brake mechanism in the wheels of the car. The area of cross-section of piston X, the smaller one, is 4.8 centimeters squared. So A1 is equal to 4.8 centimeters squared. So cm squared. Notice it's in centimeters squared. So do we need to change it? 4.8, no need for that now, it's okay. And the force, why don't we need? Because we can also measure pressure by Newton per centimeter squared, and whatever we get later, it will be in centimeters squared also. And since in centimeters squared, the other area is not given. Is it given over here? Let's find out. No, it's not given, so it's safe for us to use this for now. Okay, we're going to calculate for the area. No, pressure. So P is equal to F by A. Okay, F by A. The force F1 is 90 Newton. So 90 Newton divided by 4.8. So 90 divided by 4.8, let me calculate. 90 divided by 4.8 is equal to 18.75 Newton per centimeter square. So that's the pressure. Let me just write where will we write? Okay, here 18.75. It's not Pascal this time because it is in centimeters squared. So Newton per centimeter squared is what we will write as an SI unit. You don't need to convert to Newton per meter squared. That's enough. Okay, so that's the first part of the question. Question number 2. Now, let's go to the second part of the question. The pressure on piston Y is the same as the pressure applied by piston X. But why is it that the force F2 is greater than the force F1? What's the reason? So, we already know that P is equal to F by A. Okay, and we learned in our first lesson of pressure, the smaller the area, the bigger the pressure applied, and the bigger the area, the smaller the pressure applied. So that's mainly the reason. So area of Y is bigger, is higher, therefore the force than the area of X, so force is greater, so you have to write it that way. And that's only 1 mark, so basically they're just testing your knowledge on pressure. what's the effect of small area to pressure, small area, and force on a small area, force on a larger area, what will be the effect? Okay, so there's a question number 3 here, but I'm not gonna answer. You're going to answer it in your notebook. Okay, I'll give number 3 for you to answer in your notebook, and as well as question number 4. Here's question number 4 over here. Yeah, question number 3 has 2 parts. You're going to answer that in your notebook. And question number 4 is basically questions that will summarize the lesson for today. Okay, so you're going to answer all of these questions in your notebook. So what have we learned today? We learned the working of hydraulic systems, and we also explained the working of hydraulic systems and how force is magnified. So that's it for today. Again, this is Miss Teresa. I hope you enjoyed the lesson. Have a nice day.